Hey guys, how you doing? You awake?
Waiting for pizza?
Pizza's coming. All right, I'm Keath Nupuf, and this is Nick Westerlund.
Right. And I'm Nupuf, as maybe a few of you know. And we're going to talk about non-disruptive backups. Now, we chose to actually talk about LVM in specific, with encryptions as well. So we're going to kind of look at the secure storage of it as well, and how to create those things in the least disruptive way. So yeah, I'm a DBA obviously, and
I'm mainly a security guy. I work on breaking into systems and how to make systems more secure, and we use MySQL in our institution, and we love it. We've been using it since about 94, 95, from the beginning.
so often have you broken it?
Not too often. At the beginning, I broke it a lot.
Yeah, so it says here, I don't want the world to end, and I guess neither one does it because we don't want anything to stop when we do our backups. Now, of course, you can do it on slaves or anywhere really, but we're going to look at doing it on a single server here, and data grow. And the more data you have, the more time it's going to take to do the backups, and we don't want anything at all to stop. So we're going to look at exactly how to do it and see what we can do and how much time we're going to have the data available.
Okay, and for the most part, we're looking at single server solutions, customers that have small websites, development servers that you want to be able to do massive changes. So you want to take a snapshot, make a big change, roll back to the previous version, and you want to be able to do it quickly so that you're not wasting too much time on a production box or a development box where you have people waiting. The reason we picked LVM, there's a couple versions of logical volume managers. The one that's on Linux is free. It ports over to a couple different systems. The one on Solaris rocks. It's really good. But if you're on a low commodity server, you're probably going to be running Linux.
Yeah, and your Veritas,
Yeah, the Veritas volume manager and all that stuff also, which is also really good. It does the same kind of concept, and it allows you to group disks, do snapshots, and I guess ZFS is going to be the new big thing, so you can do more than just snapshots. You can actually snapshot and then mirror partitions across multiple servers, but I guess that's the kind of holy grail of file systems.
right. And
It's coming.
Oh, it's kind of right there. So yeah, we're saying is think a step ahead, planning. It's all planning as well. So Keath already mentioned we're looking at small installations like development boxes, single server solutions, anything that you just have to do in one sort of backup one. And for example, if you do testing and you know this data doesn't change and you want to test something and you just want to have a quick fallback in case something happens, something blows up, those kind of things.
You just did a huge alter table and you want to be able to roll development servers back to where it was a few seconds ago. So you can do a snapshot, make your alter, go, wow, that really didn't do what I wanted it to, roll back to your original file system and you're up and running again.
Right, but hopefully you don't do an alter table and it didn't do what you wanted it to.
Well,
hopefully, yeah.
That's what your programmers are doing, right?
It is.
LVM, like I said, it allows you to abstract storage devices. You can take many disks. You can take many USB sticks. You can RAID USB sticks. You can do all sorts of really cool stuff with it. It's just all about playing. All right, so...
So we're actually going to do lots of screenshots. I hope you guys can actually read what it says, but it's VG display. It gives an output and saying, okay, we have this much data available in this pool, the status of it, and so on.
Yeah, so basically what we're looking for here is the free PE size to find out how much space we have to play with for creating a new volume. So we're actually going to go through creating a volume. We're going to go through snapshotting it. We're going to go through mounting it, backing it up, encrypting the backup, and then destroying everything and walking away with the secure backup.
Yeah, and as well as actually creating a key to...
Oh yeah, plus we're going to go through a really quick preview of just using GPG. So basically, this is VG display. You can basically run through this, get some real quick information about the server, and find out how much space you have to play with. Then you use LDCreate to actually create the volume. In this case, we're creating a 250 meg volume on the disk, and we're going to designate it with the name of my DB.
Yeah, and you might want to be careful because it's easy to type in G instead of N.
Yeah, I did that yesterday when we were testing this.
So yeah, then we format it, we create a file system on it, obviously. Standard stuff, I'm sure everyone has done it. And we use the dev pool, because the name of the group is pool, and we call it MyDB when we create it. So now we have a disk, and we're going to use a virtual machine for the testing the examples here. It doesn't have to be virtual, it can be real as well, but we use a virtual machine, and we can set up encryption, and it's all free.
Yep. By the way, Zen rocks. So what we're going to do right here is we're going to actually create a, now that we have a partition, we're going to mount it within our Zen image. Zen is a virtualization system, just like, it's basically what Amazon used to build EC2 off of. And so we're going to bring up a new host on the Zen server that we just created the image on. So we're going to mount that as a physical volume here. So what we have going on here is we have a couple of Ethernet devices, we have memory allocated to the server, we have the kernel that is running, and then we have the image file, the name of it, yeah. We have a swap file, we have some sort of an image file that might have web folders in it, or client data, and then we have the actual physical device that we created in the last step. By the way, all these will be available online, so you can actually go back and look at them and cut and paste. Yeah. And then we're going to mount our root partition, and we're going to send a few kernel things in. It's just like as if you had a real Linux box, you're sending stuff into it, except it's all virtualized.
So all these files are integrated, they're in here. Just the output so we can see what we're actually doing. So we're listing what we currently have, and we're setting up the new server. It's all there. It's very easy.
Yeah, so XM list basically lists the active images that are running on the server. XM create, you call the config file, and then there it's running for a whole, 5 seconds, 8 seconds?
Yeah, and now we're actually inside the server. We're inside a virtual server, and as you can see here, everything looks as a physical disk.
Yeah, and also notice the no A time. Make sure when you guys are running databases, set the no A time flag on that partition. It's going to speed up your performance tremendously. You're not going to be fighting with the Linux file system at that point.
And doing unnecessary writes.
Exactly.
So, we have our server up and running, we have our disks up and running, we're going to set up encryption, and we're using GPG for this. Mainly because it's free, and it's easy to use, rather quick.
So this is the quick, how many of you guys have actually used GPG? Excellent.
It's more or less 60%.
Yeah, it's a great tool. Who doesn't use GPG and uses something else? Oh, that's very nice. So just go through creating a key.
We're saving lots of time.
Yeah, exactly.
Right, so we actually thought about these things. We had a talk, me and Augusto from Percona yesterday, this morning, about how to secure passwords, how not to store them in plain text files and so on. And one way of doing that would be to actually send it into memory space and maybe even scramble it. So what we chose to do here is actually scramble passwords.
Yeah, we just sent it into BZ2 and outputted it into a file. Usually you send the file and make it read-only just for the user, or read-write just for the user. So 700 or something like that. And then we're going to export it back into the shell as we're going to run commands.
Yeah, and also, of course, at this point, we don't really want to keep passwords anymore around once we have the password. So it can be removed, we have it safely stored away. Just don't do that in your terminal, because people may be able to see it.
Yes.
You will be able to see it at least. So, yeah, so I'm sure everyone here has done snapshots of your databases at one point or another. And it has its drawbacks. We're not going to go into drawbacks and pros and cons about it. One of the things is that if it's in a DB, we can't really guarantee that it stopped writing even though we flush data. So it's something to be aware of. It may create problems. keep it in mind. But we're using it here, and we're assuming, for example, that you're using MyISM or a similar database engine. So we're flushing tables. It can take a few seconds, and then we're actually going to flush them again and lock them. Yes?
Does the read lock go away when the command returns?
No.
Yes.
It does?
This one does.
What was it supposed to be?
This one does because we send it in as an execute. But you open up this separate session and you do the read lock in that one, keep that session running until you're done with the snapshot. I'm not really sure why we missed that, but yes, it does. You're right. Since the session is closed, you're doing -L -e execute and
Flush the locks out.
no, and by the time you're done, the flush table will read lock. It's going to release it.
Per session.
Per session, yes. Well, actually, because the session dies.
Yeah, the session dies when you get logged out.
Yeah, and then it's gonna unlock it. But yes, log in with a separate session and do it. Can still be scripted though.
What you could do is you could add a sleep to the end of one of those commands
Exactly.
and make it
background.
long enough, and then remember the process ID and kill it.
Example. Yeah, keep it in a separate session.
I mean, you most likely can just set it for 1 second, because we're going to show you why in a second.
No.
No, that's not enough. I don't think.
For
It might take long.
after you've already done the first flush.
It might take longer, yes, but set it for a few seconds. Yes, test it right. But yes, it's a good point.
I'd do like a huge amount, hundreds of seconds, just to prevent a race condition, then come back and kill it.
Right,
Okay.
especially, for example, within a DB, it may happen quite often.
Good call.
Yeah, so we're now looking at creating a snapshot. Now, you might want to do this.
Yeah, so basically, we're going to go ahead and create in this case, we're creating a 300 meg snapshot. You usually want to make the snapshot equal size to the size of your volume. So that way, if you're writing deltas out in the file system, within the snapshot, basically what LVM does is it actually creates a snapshot, makes a delta point, and then keeps track of the changes going forward. Which is also, you don't really want to have snapshots lying around for a long time, because it's going to start degrading your performance tremendously. But for short times, it's really good.
Right, and also here we have the unlock tables, which of course, by that time you grab the PID of the last one that you created and you kill it off again.
We'll have to update that in the slides.
Yes, that will be done before we publish the slides, don't worry.
Then we're going to go ahead and we're going to remount the file system as read-only.
This is actually done, in our case here, we do it on the host server.
Yes, this is actually done at the Zen server below the image. So it's not actually in the guest, it's actually done at the base server, at DOM0.
Yeah.
Yeah, so here's a quick little tar script that allows you to basically pass in to GPT and run it through BZ2. You can go ahead and change the compression level. With BZ2, it's amazingly great at compressing stuff really tight. The compression levels, you're going to see, depending upon the type of data you're compressing, you're going to see a decent, it's really not enough to go past the defaults. The default is 6 as far as the compression level goes, and you don't get much benefit by going lower or higher as far as speed or size.
Yeah, so it's a very good default.
But your mileage will vary depending upon your data. If you have a lot of white space, you'll lose all that right off the top, even though you're going with a 1.
Right, and at this point, of course, we have no more logs. The database is running while we're doing all these tars, so nothing's gone. What it may do is that it may add a little bit of CPU, because we have to do it, but we're going to tar that onto a different physical disk, so we don't saturate the I/O and different controllers and so on. But once it's done, we have to clean everything up. So we're going to remove, well, unmount what we just mounted, the snapshot, because we don't want to keep it around, as Keath said, for basically with Snapshot it keeps the differentials between everything, the deltas. So the more data you change, the slower it's going to be, and the bigger it's going to.
Yeah, so you want to get in there and destroy it, unless you really need it around because you're doing some alter tables or something wacky, and want to be able to recover back to that in a quick manner. And here's what we got for our mileage.
Right, but we actually have to say that in this case, we still have the problem with the flushes, so.
Yeah, so we did have some load going at this time. These are in nanoseconds, so drop what,
Billion?
a billion?
Yeah.
And then you'll be at seconds?
And also for the sake of this test, the data set wasn't that big, and I made we used Giuseppe's
Was it 200?
megas, 50 megs, whatever it is, the one on Launchpad, the test database. So basically, we went through what we did here is we flushed everything, flushed the logs. As I said, we have everything here in nanoseconds, and everything went through. So as you can see, everything is pretty quick, except for the amount of lock time totally, and the mounting and so on. The longest thing by far will be afterwards. So
Yeah, and then also so our final result was, it was basically a third of a second for the whole process to get the snapshot. You really want to write the tar files off to a separate disk so you're not affecting, if you can get it even off to a second physical volume, so you're not affecting the disks that your database are on.
disks, controllers,
Yeah, whatever.
all the way, yes, we'll
Yeah.
avoid doing that.
And then also send it off to EC3, send it, SCP it somewhere. It's an encrypted backup now. They have to have, it's PGP.
Right. Don't lose your private key.
Yes, don't lose the key. And test your backups. Please, please, please test your backups. Run through actually decrypting it once, decrypt it once a month. Make sure you don't expire your key out. You're going to lose your backups.
Restore it.
Yeah, do a restore. Restore it somewhere else just to make sure all the data looks good.
So, yeah, that's basically our last slide. But,
So this was our total walks right here.
right. So the lock time is still going to be the same time, except that we have to redo it, so we do it kind of in the background and keep the process ready as we talked about earlier. Now, this is a very basic setup, a very basic script to do it. It's one script, and it's very easy to use. Now, in case someone wants to try it, you can use my LVM backup or whatever, and that's it. We can also make this, once we actually publish these slides, we can also publish the script.
Yeah, and we'll fix the locking error.
Yes, we fix the locking bug, and then we'll publish both things at the same time.
Questions?
Questions? Yes.
I know we beat the pizza.
What kind of load did you guys have running on your server when you were doing the LVM snapshot?
It was probably about what, 50,
50-50.
5 to 50 transactions per second.
Okay.
Yeah, it wasn't that high.
What was it, read-write activity or just read, or?
It was mixed. It wasn't that much because we just generated some load.
Yeah, you're just proving a point. I mean, proving that you can do it.
Yeah, we were just more, we wanted to actually, the reason we did it is because we actually wanted to see what the real effect of it was. So in that third of a second, there's probably 20 date calls. So that's also on top of that time, so I don't know how much a date call costs.
Yeah.
It shouldn't be much.
Few nanoseconds.
Yeah, so hopefully it wasn't affecting our times too much. So our times might be bloated a little bit just from us trying to get more granularity.
But that's also, you bring up a good point. I have clients that uses these kind of things in production, and it is working. But there is a few caveats. For example,
XA.
XA, for example, the fact that DB does the background IO threads. But DB freeze patch is supposed to fix that, isn't it? I think so.
It all depends.
Yeah.
Now we also, one of the other things that we did do is we moved the data partition for because it usually goes into lib,
Yep.
var lib,
Var lib MySQL.
MySQL. So we pushed that into var lib MySQL data.
Yeah.
And then we talked about, all right, now you got the bin logs, which bin logs need to go where, so we did throw the InnoDB bin logs into the data folder. We threw the replication bin logs over to its own bin directory. So they're not actually in the same file system that we're actually trying to snapshot.
Good way to run it.
Still not good stuff, but yeah. So, any more questions? We were a bit fast, actually, which is good.
Yeah, you helped me catch up 5 minutes. So we've
That's good.
got the next talk up, high performance airline. So